Welcome to Study Loop.
Hello everyone, today we're doing chapter 23, problem 62, and this problem asks us to draw the stepwise mechanism illustrating how each of these products are formed. So let's do the first row first with LDA. So LDA will generally form your kinetic enolate, in which is going to depronate the least sterically hindered alpha carbon. So if I redraw the starting material here, we see that the least sterically hindered alpha carbon is going to be this carbon here. So we will have the base being LDA, so I'll say LDA equals base, is going to rip off this proton, generating a carbon ion. Negative charge. And then what can happen, we're going to have an intramolecular cyclization occurring because this carbon ion is very nucleophilic, and this carbon that the bromine's off of is very electrophilic. So you're going to have an SN2 backside 180 attack to form intramolecular cyclization to form the major product as illustrated here. Like this. But alternatively, what can happen is that the base can alternatively rip off this proton here to get an elimination product, as you see in this product. So you can rip off this proton, making a bond. You make a bond, you break a bond. So the sigma bond will make a new pi bond. You make a bond, you break a bond. So bromine will fall off, and this will make now your elimination product. So now you have your elimination product. But additionally, what can happen is that even though LDA only takes off your least sterically hindered alpha proton, it can also take off potentially other alpha protons, even though if they are sterically hindered, such as this proton here. So alternatively, your base can pick up this proton to form an enolate, a negative charge here with and I can go through some enol ketotautomerization to form a new pi bond here, and then this bond will go up to the oxygen nucleus. Now you have an O minus, a new pi bond. And now this O minus will act as your nucleophile, and this will undergo intramolecular cyclization because of that proximity of that electrophilic carbon. And now you will form the product you see here. So this last one can occur with both LDA and potassium tert-butoxide to form this product. But an additional reaction with potassium tert-butoxide is you will form the thermodynamic enolate. So now your potassium tert-butoxide, it is not as bulky as LDA, so it can fit into this crowded space here and depronate this thermodynamic enolate to form now this carbon ion at this tertiary position. And then this can undergo intramolecular cyclization to kick off the leaving group bromine to form your last product here, which is a cyclobutane, which is not actually that favorable, just like this.